Hi everyone, and today we all here for getting into the subject called speed sensor testing and failures in three-phase traction motor. Traction motors. Okay, I am Kesavamoorthy. I am looking after traction motor system. Apart from the traction motor, these are all the accessories for the traction motor. What are all the main accessories we can say? Traction motor is a component that is confined of bigger things: rotor, stator, and pinion. Okay, that is confined to traction motor. These are all the sensor which is essentially required for the rotational speed has to be sensed. Okay, as like that, there is a temperature sensor is also there. That is also mounted in the traction motor, but it is not a part of the traction motor. Those are all the accessories. Okay, you just recall there are two things. In this day, today we can slightly discuss about the speed sensor matter. Okay, anything whichever equipment or components is getting involved in circuitry of a loco, everything will has its own technical circular because the objects will be new and what we have to follow. What are all the technical aspects covered in that will be already will be covered by RDSO. There is one TC is available 2008. It has been released in the date of 21/8/2024. So in this technical circular, there are testing methods also has been explained. Interchangeability and maintenance. How it has to maintain a Hall effect speed sensor. Okay. Before go for speed sensor, we will have just a talk. Speed sensor. When we say speed sensor, what suddenly comes in your mind? Speed has to be sensed. So bike or car or something. Okay. When speed means something object is rotating, that has to be conveyed to dashboard. That's what we are seeing in the bike as well as car. So for checking that direct contact tachometer, you can heard about the tachometer. So whenever a motor is rotating, in all the shaft there will be some or conical thing will be given. So if you put the tachometer there, tachometer also will rotate according as per the speed of the shaft. So tachometer itself have its own display. There we can see the display. We can say what RPM the motor is rotating. So that is on the conventional and old method. So another thing coming is non-contact tachometer is also there. Suppose if you place on a reflective sticker, then infrared lights will be passing. So that will cut each and every rotation. It will make a cut and break. So that is also counted through electronics. That also will be displayed as a RPM for a particular motor. Okay. So these are all the certain different applications. Still, it is being used in elsewhere. Okay. When it comes to the traction motor, then you can say conventional locomotive. There are speed sensors available. In that, what there will be to sense the speed of the loco moving. There is only one speed sensor is mounted in the conventional locomotive like WAP4, DC, WG7 and all. Only one axle will be fitted with a PG ring. So when one axle is rotating at one speed means naturally all axles are rotating at the same speed. So for defining the speed of the one locomotive, sensing the one rotation is enough. So that's what in conventional locomotive and all you can see there will be one pulse generator ring mounted in one axle. So from that some signals are generated and speedometers will capture. So speedometer capture and it will display the speed. That's what the thing is happening in the conventional. So now when it comes to the three-phase traction motor, actually here the technology is everything is totally different. So three-phase traction motor means the motor itself is controlled by some variable frequency kind of method is there. So the concept of because fully it is driven by electronics. Total from the we can say SR because in conventional you can say transformer then GR it will give the voltage. Here you can see there is a SR. SR will do all the process of controlling the traction motor. There are big electronics are there. So now we will go to the subject. The rotational speed of the traction motor access to the speed sensor three-phase locomotive. The transfer converter, that's what I say, traction converter. That is called SR. That processes the speed signals. The converter processes speed signals. Okay, the speed signals received from the respective TM and detect the differentials between the speed signals from different TMs and calculate the slip. Okay, so you can see the word differential between the speeds. So what it says, a motor is rotating at one speed, another motor is rotating at same speed or not. That is being checked. So to go to we can go back to the conventional method of speed sensing. Since there is only one speed sensor, it is not confined to motor. So the differential between the speed of each motor is being sensed by the QD, differential relay. Current differential relay is mounted in the electrical side. So that current differential relay will check continuously, it will monitor the current of the two traction motor. It will monitor just what is the current taken by when current taken is varying between the two traction motor, then it is being there is no electronics and program like that. So automatically it will sense and will give a signal like that. That is what one motor is rotating at one speed, another is rotating at different speed. So motor will be isolated. Like that it is being followed in conventional. Now when it comes to now we say each and every traction motor is mounted with a speed sensor. So what it says, each motor speed is captured during the movement. Each traction motor speed is captured by means of the individual speed sensor mounted on the traction motor itself. Okay. Here you can see. So when it comes to traction motor, you might have seen all the traction motor now. Finally, if you see a traction motor on the visible part outside, what you can see? One end of the traction motor, you can see the pinion. And everybody familiar with that, no? So pinion is the driving end of the traction motor. It is engaged with the axle on the one end. Okay. Then where does the speed sensor comes? Speed sensor, where it is being mounted? It's obviously it will come to the opposite end. What you are seeing in this figure, it is the opposite end of the traction motor. Here you can see in this end, for a proper fitment and procedure of speed sensor, one speed ring is essential. Okay, step by step we can see. Here we can see a speed ring. The speed ring is directly mounted on the shaft of the rotor shaft of the traction motor. On the other end, what it will be? Pinion will be there. Now it is in the non-drive end. In the non-drive end shaft, with some arrangement, the speed ring will be mounted. Okay, because you can see the speed ring is having this kind of zigzag. If we can see it, say it as teeth. So totally there will be 120 teeth. Majority of our locos are fitted with the 120 teeth speed ring. That is called tooth gear. Teeth gear wheel is mounted. So then after that it will be covered. It will be covered. So this is the speed probe housing. That enclosure will be totally covered. So here it comes the role of speed sensor. Now the speed probe housing is the area where we can fix our speed sensor to this. You can see the speed sensor is being just a 2-bolt fixing arrangement is enough for mounting this speed sensor. In this area it will be fixed. Okay. You can read through. A typical Hall effect sensor has 3 wire terminals, one for ground, one for supply. These are all the electrical arrangements of the Hall effect speed sensor. To produce the output signal, a Hall effect sensor must be supplied with a reference voltage. Because Hall effect sensor is an electronic. The concept of sensing the speed is previously we saw a tachometer. We just assume this as a tachometer. It is a non-contact, but the working procedure is Hall effect methodology. Hall effect methodology, that electronics also needs some voltage has to be supplied. There is an electronic PCB is also there in the sensor. So this Hall effect sensor has to receive certain voltage. Where does the voltage will come from? There already we discussed now SR. SR1. SR1, what are the motors it will cover? SR1 will cover TM1, TM2, TM3. So similarly SR2 also 4, 5, 6. So from the SR1, suppose we take TM1 means from there will be some voltage is coming. So the designed our Hall effect sensor is designed to work in the 15 voltage supply, because something has to be standardized now. So all the SR will give an output of 15 volt. The SR has been designed like that. So input voltage for the working of Hall effect sensor is 15 volt. So next, Hall effect refers to the phenomena. So here it comes the basic working of the Hall effect sensor. It's a phenomena that when an electric current is applied to a piece of metal inserted between 2 magnets, it creates a secondary voltage in the metal at a right angle to the applied voltage. Okay, this is the phenomenon because it is a non-contact type of version. So reliability should be much more very stronger, because we can't directly place one infrared sensor mounted in the traction motor and become, because reliability is very important. So this Hall effect is proven to be a very strong and reliable. It will not often get failure because of the malfunctioning inside the circuitry, because there is no wear and tear management are there in the Hall effect sensor. The principle of Hall effect is just like when a magnetic field is just enough. So it will be working for a last long. Simply to say, it is a very maintenance free kind of speed sensor. That's what this Hall effect phenomenon has been implemented for our locos. Okay. Because the Hall effect concept, we can take it deep in the another sessions also. Just you can imagine, Hall effect sensor, what does it need initially? Because a 15-volt power supply from the drive control card, that you will be naturally getting from the SR. Then IGBT speed sensor. So here you can see the speed sensor has to give one pulse, then we see the output. So that sensor itself, you can see still stainless steel part is there. That is a sensor. The electrical things, what it comes in the sensor is to make the sensor to work. There will be a 3-pin control. Later slide I can show. A 3-pin will be there. That will take care of the incoming supply. Then the sensor will again produce the output waveform. It will give back to the pulse generator. In that, then from here it will go to the IGBT. IGBT will take the output from the sensor also. So the speed sensor used is a dual output. So this you can see the speed sensor used in eLoco project uses dual output for sensing the direction. These sensors produce two square wave output at 90-degree phase shift. Okay, depending on which output signal is leading, the direction of rotation is determined. The speed of the rotation is proportional to the frequency of output signal. So this much things is a square wave. We will be already commonly we all knowing. Okay, this in the next slide I will say. Okay. To the clarification, now what we are seeing in this slide is the A, B, C, D. Okay, D, E, D is there. So for generally, A will be giving one output, and also B will be giving one output. This what you are seeing here is the output of the Hall effect speed sensor. This from here, this output from the speed sensor is connected to this point. Because these are all the one junction which is coming in the loco body. So when it is connected, so from here only the line is going to the SR. So just for our understanding, I have put A and B. So just it's a type of the different types of speed sensor being used in the our locomotive. You can see this is one speed ring, 120 teeth. This speed ring is having 200 teeth. Only BTIL SR make and all, it is being used with the BTL Leonard Baird maker. Another is 5 plus 3 pins 120. This is one type of ARC. Some more other types also there. Jackwet, this also one make is there. So this is the structure. Normally what you will see here is it's all metallic portion. This one portion, this is the area where a magnetic pulse will be always passing towards the tooth gear. Towards the tooth gear. This is also another type of sensor being manufactured by Meda, the firm Meda. This is also 120 teeth. These are all designed for sensing the 120 teeth speed rings. Then next one. Speed sensor interchangeability. This is a maximum it is confined to TM section only, but for your understanding purpose you can say. Just you can see make of the traction converter is ABB. Okay, ABB. So now the sensor make is what are all the sensor make, this ABB will accommodate for its working. ARC, Jacquet, Leonard Baird. So all are 120 teeth. When it comes to BTIPL only, this particular firm only handling, they have designed it for speed ring to be fitted as 200 only. Whereas all others are standardized to 120. Only BTIL is having a 200 teeth, because this square wave output from a 200 teeth sensor, that will be different. So according to the output of 200 teeth speed rotation, this will have a different square pulse. So this is totally programmed like this. BTAL 200 teeth. Whereas all others are 120 only. 120 teeth. Almost all square wave output of all these makes of speed sensor will be identical only. They will be same only. And the same thing only. Tooth gear, how it looks like this. This is 120. That is, since it is 200 is available. This one. Okay. Still, before we go for testing, it is anything has to be interacted. Something regarding this. Okay. So now this is the test bench setup. This also how the speed sensor has to be tested. It will be covered in this SMA 252. As per the requirement, these are all the components, the equipments required. This you can see the normal oscilloscope. Then it is just a regulator because speed sensor has to be tested at right from the low speed to high speed, as low as possible. Because the speed, as we know, train is moving right from the zero start, it goes to high speeds. No? So speed sensor has to perform its role, producing the square wave output in all kind of speeds. So a regulator is there to reduce and decrease the speed, increase and decrease. So the speed ring is mounted. Now it's a simulation setup. Behind a small motor is there. The small motor only is made to rotate. So this ring will be rotating. Okay. Then here you can see earlier we discussed now that tachometer non-contact type. Why? Because we have to just measure the rotation. Now this oscilloscope is meant for what? As we discussed earlier, this speed sensor will be providing an output. That output we are saying is square form. What we see in the paper, everything is square form, square wave. So really, it is a square wave or not. That is will be easily displayed in the captured, and it will be shown for our eyes through this oscilloscope. Then we are talking about speed now. Suppose this motor is rotating. So what is the speed? The speed ring is rotating, we don't know. So for that, we need this tachometer. So by using the tachometer only, because the regulator can adjust the voltage, but what is the speed we have to test for that only for that tachometer. These are what speed sensor testing. When the setup is already there now, what you have seen in the earlier slide. So pulse pattern of speed sensor receive the IGBT traction converter as shown in the figure. IGBT traction receives the control supply from the rack. So the speed signal is in the form of 290 phase shifted square pulses. In the next slide is that images and all we can see. Okay. This is what. Right from the 30 RPM, our testing will start. When 30 RPM of speed also, then it will start displaying the square wave. Accordingly, each and every RPM, the square wave will be having a little bit variations. So, but it should be identical. So that will be sensed. The sensor probe is fitted at a gap of, this is the first time we are coming into 0.5 to 1 mm. What is that 0.5 to 1 mm? Where is that gap means? Sensor we have seen now. Sensor will having our cylindrical portion. That is the end of the sensor. So speed ring already we have seen. Speed ring having a teeth arrangement. The gap, the distance between that speed ring as well as the sensor, this gap is only 0.5 mm to 1 mm the gap. With this gap, because it is a more gap, the magnetic, that it's all working on a magnetic. Whenever we increase the distance, the magnetic effect will not be there. Okay. So that's what as minimum as possible and as maximum, some limitations has been already fixed. By setting in this setup only, we have to do all the testing. So when we gradually increase the sensor generates voltage by the movement of the pulse ring. The magnitude and the frequency of the pulse generated is measured and monitored with the help of the oscilloscope. So magnitude and frequency. Frequency, this is now frequency now. When speed comes, how the magnetic, whenever we given already 15 volt is readily available in the sensor. So sensor will be generating a constant magnetic pulse. By means of the variation of that variation of the speed, so this here the sensor is not mounted in this picture. Sensor will be passing a magnetic pulse downward towards downside. Sensor will be mounted here. So when the speed ring is rotating, it will cut the magnetic pulse. Each one teeth will be cutting the magnetic pulse. That small changes now. So that is being sensed. So according to the how many times it cuts, according to that some pulse will be generated and it will be shown here. So the motor is run at variable speed in difference by measuring the voltage and frequency generated. The condition of the pulsing is sensor with respect to standards conveyor. Before that I can show before. So in this way a square wave will be generated in a, when we test the speed sensor, this way it can be sensed. Because similar kind of setups and oscilloscope and all not available there in the SR electronics. SR will it will sense only the thing because there is no display arrangement. SR is programmed to receive the how the square waves are there. Any these magnitudes and all it will be magnitude means having a certain kind of voltages. So when voltages is varying, SR will sense capture and measure only the values from the speed sensor. But here we have to simulate through the oscilloscope. These are the way. This is also explained. Now we can see this is how we can say we have the two pulses, but only one speed ring. But how we are getting two pulses here? Why? Because when that teeth itself having on up and down. Speed gear teeth is having a figure on teeth will be like this now. So whenever the top teeth cuts the magnetic field, so it will actually when it is cut, some voltage is getting reduced. So accordingly, it will be the electronics is made to say it is a high. It is high has been made. So when it passes, after cutting it passes again, then a down is there. So that is also it is generated in the down. So from that A and B output we have seen now. So accordingly, two sensor is required. Normally for checking the working, one is enough. One is enough whether it is working or not. Now why this is because the speed direction is forward or reverse. For checking that one logic is there. When this is you can see here at 90-degree phase shift is there. When it is 90-degree, this is coming down, this is it high. When this is now it is low, and this phase shift of 90-degree is always happening. Now this phase shift also should not change. Suppose phase shift disturbance means that again also speed sensor will not work. Not only the square form, we have to check all the phase shift also. So for that, this way, this is the perfect thing. Channel 1 and channel 2. This way it has to be available. Okay, in this chart you can see these are all the readings as we just told earlier from the 30 RPM, 50, 100 like that. This much of RPM we have to test. So we have to actually what it is in when we are measuring in the tachometer when we see 30, the standard square frequency in pulse it should give 60 because this 120 teeth it is like that. There is a calculation of formula. When it doubling above the speed should be the frequency. So this in this order it will be same, will be featuring. So for forward also it should be same. Here you can see pulse magnitude or output voltage. This is also to be measured. For all different speeds also, pulse magnitude also will be varying. So in the next slide you can see, if wide variation in frequency 30 means 60, doubling up should happen. If wide variation frequency are measured, pulse generator ring is defective because in this way we are not only testing the speed sensor, the pulse generating ring also it can be tested. So variation is occurring frequently means there is some damages in the speed ring also. Then to check the efficiency of speed sensor, the only thing is the voltage. For new speed sensor, it should be less than 350 millivolt. When it is in service, it should be 250. But any sensor going below the 250 millivolt, then we can declare it is a failure prone, even though it shows some good square wave output also. Okay. So these are all the sample waveforms. Here you can see certain kind of small ripples are there. So generally due to the electrical disturbances and the circuitry issues. Otherwise, it should be pakka straight line. It's a normal waveform. This is having certain distortions. These are all the sensor we released from service. So it's having some this area spikes also some distortion happening. So this is showing error also. This is another. One channel is completely not producing any signal. So this is also one sort of defect. So as we discussed, the gap is an important criteria for maintaining the speed sensor. You can see 0.4 to 1.5 mm is commonly given for a speed sensor has to be this much gap has to be set. But due to the, as we see our RIP, because measuring this setting is a very important critical criteria matter in that. So for BTL maker, generally because of our experience, we came to know when we keep 1 mm like that, because even though it is in the standard 0.4 to 1.5, if we keep 1 mm for this BTL sensor, sometimes it may malfunction. So for BTL sensor alone, we are trying to minimize as minimum as possible. So 0.6 to 0.8. Because these measurements are all very less, very less. What will happen if we wrongly measure means the speed ring will come and rub with the speed sensor and the speed sensor will get damaged immediately in the first trip itself. So BTL make we have a lesser population. We are stringently maintaining this 0.6 to 0.8. So after setting this 0.6 to 0.8, maximum all kind of speed sensor fault errors and all minimized. For rest of the thing, because BTL is a 200 teeth sensor, ARC, Jacquet, MEDA, these are all 120 teeth. For these type of sensors, maintaining 1 mm is sufficient. So 1 mm is being maintained for all the other type of sensors. So that is nothing because how the gap is being checked. Whenever a two object are there, we want to check the gap. Simple method is we can directly insert some feeler gauge. Feeler gauge if we insert, according to that we will get. But as per the design of the speed sensor and all arrangements, simply externally we can't insert any feeler gauge to measure this as minimal said 1 mm point, this 1 mm gap and all. We cannot able to because there is no external hole opening and all not there because it is very close to the bearing area. So for that there is a alternate a method has been utilized, a mathematical calculation. So that is called, it is mentioned A minus B, ND cup, B is equal to speed sensor. These are all the practical measurement. So this in this way, whenever a speed sensor has to be mounted, now you can see speed ring is here. So this will be mounted here. So when it comes closer, so what is the gap in between? No one will know. So this gap we have to arrive only by means of the measurement method. We using this digital depth gauges. So depth gauges will measure. Assume the speed ring is here. Speed ring will be here. So from this phase to speed ring, you will get one reading. Then after that, from this phase to this one, you will get one reading. So the two reading we have to keep in hand and we have to subtract. So what is the gap? What is the thing it is coming? That is the gap. So for these are all the locally made tools for measuring and setting the exact speed sensor gaps. Directly, because two measurement is always required because this depth is also there. There is one, there also some gap. So two has to be measured and calculated. Okay, here speed sensor old practice, Jacquet and Lenarbert error mark. Why? Because by seeing a speed sensor, we can't immediately distinguish that whether it is a 120 or 200 speed sensor because the make of the company and all will be engraved here. As far as the design is concerned, it is looks as same, identical ditto. So what happened earlier for 200 speed ring, another 120 also will be fixed. For 120 speed, that is also one important criteria. Whenever it goes speed sensor, the design everything will look same. So the people have to clearly read and identify and take the proper speed sensor. But apart from that, even though one person has selected a speed sensor, correctly he has taken 120 teeth only has to be fixed. He has taken. The another thing is when the speed sensor has to be mounted correct position instead of up and down. Even if I tilt and provide, that time also the speed sensor will get accommodated. Then what will happen immediately when loco taken first notch, that itself it will not allow. So to initially it was available, but there is one foolproof method is also there. As I said now, a speed sensor cannot be tilted and fitted because there is a speed probe housing. In this housing, there will be a pin projected outside in the top side like that. So a person is tilting means it will not allow the sensor to get fitted. There is one foolproof method. What Then what happens, because it is just a pin, many cases pin has fallen out. So after that, when we go, these are all the slots provided for accommodating the pin. When pin is not there, then there are chances of a manual error happening is there. It can be ulta put and it can be fitted. So this was happening in the beginning stages. These are all not happening now. I'm saying before 3 to 4 years. So what we have finally identified, we have put on a arrow mark. These are all the, in what way it has been evolved, that's what I'm saying. So we decided one arrow mark we can put upside down, like in many parcel and all it will be there. So like that we put a arrow mark to be done while releasing the sensor like that. Then critical some distance also there. These are all very minute distance to sense, but the arrow mark we have provided. Then finally, according to that, so now everything is being fitted. Then again we have to make it convenient for user. So what we changed, you can see a sticker has to be pasted because with a wide population, when 10 or 20 speed sensor is there, how to easily identify? For that, we purchased on a reflecting sticker from the local shop. You can see Leonard LB. Leonard LB means what? 200 teeth. So 200 teeth, we have defined a color category for yellow. So those yellow we have pasted in all the Leonard Bear and the 200 teeth sensor. Again, to distinguish the other 120 teeth, we have purchased a red color sticker. So that 120 teeth we have pasted for all 120 teeth sensor. So here itself we have concluded one important matter is whenever a sticker is to be pasted, it has pasted in the downside. So automatically what happens when anybody is going to fix the sensor, he will ensure the sticker is in the downside. So after these arrangements, those kind of errors are totally nullified. It's a simple thing. At a cost of 100 rupees, it has been cut and pasted. Now it is successfully, we have got a failure-free things in this area. Okay, sticker is not available. Paste in the bottom side of the speed sensor while fitting back into. These are all small RFPs. So as we discussed, whenever any error comes, so instead of all these maintenance practice, we are maintaining the gap. We are testing the speed sensor and fitting the speed sensor. Even though already I explained, Hall effect means it's a failure-free service. Even though some errors are happening, so that minute error, there are chances error in the sense we can't say everything is as an error. These are all some indication. Because the speed sensor is mounted to serve the purpose to monitor each and every traction motor's behavior. Suppose a particular traction motor making a wheel slip and it is simply rotated extra for a moment, for a fraction of a second. That also will be sensed. It will be sensed as some error messages are there are different. What you are showing is disturbance in speed sensor motor 3. There are another type of errors also there. So what it doesn't mean, it says the speed sensor is having error. So it may be an error in the motor also, because on a drizzling atmosphere, when all 6 motors are leading motor will be rotate more. All these differential movement of traction motor that is being sensed. So this kind of all thing is being sensed because how this display, these programs and all coming, all from the waveform output. Waveform output is being converted into the text format like this from the SR. So this is this you can see M1 speed encoder failure active. In this way, different speed sensor error codes are there. So once such errors comes, obviously when the logo comes to shed, we have to open the sensor and see. When we opening the sensor, this we can say it is an ARC sensor. Now you can see ARC sensor, a rubbing mark is seen over here. Okay. From this part we have taken and seen, we can see a rubbing mark. So what does it mean actually? Whether we are while mounting itself we didn't provided a sufficient gap or like that. That will be the first question. Why it is rubbing like that? Because it has served more than 6 months, suddenly it rubbed. It seems to be a type defect. There is a portion for covering the Hall effect area. They have used some one kind of metallic portion. That is after a certain period of time, it is naturally coming out and bulging. So when because already we are setting 0.5 kind of gaps. It's very negligible gap. So this bulging naturally it comes closer and closing the gap is getting nullified because of this. So when it started rubbing, so then some kind of error generation is happening. So this is Always prone, this kind of failure is prone to this one ARC make only, this kind of bulging. This is also some another type of ARC make only, some bulging is happening. And this is another new ARC. They have already we have seen a metallic, fully metallic. Here this one sort of plastic arrangement. So as like Jacquet and other make, it is fully hard stainless steel. So in that also they have made. Here also certain bulging is also happening. So in this curvature model, setting a speed sensor gap is very critical because it's a curvature totally. So when we check the speed ring gap, it will be little. This arrangement is better suited for easily setting up the speed sensor ring gap. This is another problematic area in this. Now you can see, you can easily understand. Now the speed sensor, when we open and see, certain amount of grease is lying over there and certain grease is lying in the speed sensor. It is totally covered the sensor. So what will happen because of this? A continuity will be always there because this is a grease. So metallic particles are rubbing. So grease and the speed ring and the 0.5 mm gap is filled with the grease. So this scenario also will definitely create a speed sensor error. So this is all happening in the non-drive end. Later, by means of our greasing practices, we reduced the volume of grease what we are doing. Many sets, because especially for this speed sensor failure in the non-drive end, many sets has revised the practice to minimize the grease in the non-drive end. So accordingly, the grease input to the non-drive end also considerably we checked and reviewed. And now this error is not happening due to the excess grease. So this is another kind of defect. You can see one time we have seen because sulfation is naturally, because whenever electrical contact making and breaking, it is common for all sections also. Sulfation is seen means definitely there will be poor contact because it is not a bigger voltage or current it is supplying, very lesser voltage. So sulfation will lead to improper signal capturing. So the same thing we have cleaned and we have made it clear. Okay, this is one failure we have noticed because it is a bayonet coupler. Totally, it is coupler is covered. In spite of that, due to some extreme weather condition, something happened in this. So after that, the same loco we didn't. After clearing it, we have tried. Then it is problem is resolved immediately. And this is what happened once. It has happened once in our shed because the paint when the loco is in stand, because these couplers and all will be coming in the loco body. So for something has been unknowingly paint has been sprayed while covering the loco undergear. So after that again it is thoroughly cleaned and put back. So these are all the things it should not happen in during our maintenance. So its better way is we have to protect this area during when the locos comes for a watch. Otherwise, some sort of dust or any sort of external damage like this paint, these are also will there are chances for creating a malfunction. Oh, sorry. So this is what a simple topic. Actually, it is supposed to be cover the temperature sensor also. Temperature sensor is already some more a wide subject. So with this, I hope things has been covered. Now, because of these classes, generally what will happen, you will have an outline of what is sensor and where it is being, know-how of what is the use, where it is located, that things. So when we get into subjects in deep, so when we come across the next page, so we will have more doubts because it is not, as I told now, it is not so simple to understand the concept. The concept is bigger also, but I hope I have covered, given an outline of the speed sensor and what are all the areas has been fixed. So this is what, actually a series of classes is being happening in all sections. So this we can say it as a version 1. Version 2 will come. At that time, there will be more interactive sessions will be there. Correct now? So still, now I will put a break of this. Thank you. Any sort of